Everyone is shouting, but true wisdom operates in absolute silence. Look at this. One flip, minimal effort. Edge AI just saved millions. That's the quiet architect.
Rams would call this galaxy brain. Edge AI, restorative engineering, zero noise. We optimize global business with minimal effort. Quiet architects move the world. True optimization is silent. Minimal effort, maximum impact. Restoring balance through code.
Walk onto any active factory floor and you immediately encounter the vibration of heavy equipment operating at peak capacity. To manage this physical environment, headquarters often deploys centralized cloud software to gain total visibility. This software forces severe cognitive overload onto the human worker at the machine. Centralized cloud systems struggle to interpret normal mechanical signatures. They generate thousands of false positive warnings per shift. Faced with an endless wall of red alerts, operators adapt. They learn to mute the notifications entirely. The night shift operator does not call it an autonomous optimization suite. They call it the box that cries wolf. Once the system is muted, legitimate anomalies slip through. In biopharma manufacturing, this leads directly to ruined biological batches. In logistics, it results in untracked cold chain temperature excursions. The product degrades quietly in transit. A system that alerts a human 50 times a shift is a structural design flaw. It destroys operational agency. Dieter Rams followed a strict industrial design principle, stating, less but better. We must apply information fasting to data architecture. The primary mechanical solution is Edge AI. We move the computing power out of the distant cloud and attach it directly to the physical sensor. The objective is the extraction of actionable intelligence that respects human attention limits. Biopharmaceutical logistics reveal the exact cost of cloud latency. Traditional cold chain monitoring systems embed a good enough tolerance into their protocols. Centralized systems tolerate short temperature excursions to avoid overwhelming the network with logs. Latent damage accumulates. Biologics lose potency. Stability disputes arise between vendors. This chart shows a traditional temperature excursion. The internal temperature spikes and the data travels to the cloud. The alarm finally triggers well after the physical damage occurs. Edge AI anomaly detection learns the normal patterns of each individual unit. It establishes tight boundary lines. It identifies microscopic deviations at the very beginning of the timeline, long before a thermal spike becomes critical. These minor events never make it into the official corporate deviation log because the cloud system filters them out. Relying on cloud latency obscures real physical risk. It guarantees late reactions. Consider the physical signature of an industrial refrigerator door shutting heavily. An edge device processes that specific vibration signature entirely locally. The local sensor deletes the raw data immediately after processing. Zero alerts travel to the central cloud during normal operations. We see the same pattern in patient monitoring. Medical staff routinely ignore noisy central alerts to focus on the person in the bed. Moving analytics to the bedside biosensor cuts anomaly detection latency by 40 to 80%. Local processing is required to surface actual anomalies from ambient industrial noise. Biopharmaceutical manufacturing operates at a scale where every microscopic latency in the system is exposed. Current bioprocess lab reviews often frame full autonomy as the immediate end state, envisioning facilities that operate without human intervention. Full autonomy is physically unrealistic in the near term. The actual trajectory is the development of hybrid human-machine systems. These systems require strong local sensing. The sensor must catch out-of-spec pH behavior in real time, right at the tank. Real-time edge detection prevents the batch from failing and improves yields. Local edge processing functions as a direct intervention, stopping capital leakage at the point of production. Industrial operators know you cannot fix a noisy factory by adding a louder alarm. A failed cloud architecture floods the dashboard with overlapping warnings. A minimal edge architecture presents a dark screen with a single crisp text alert. This is the mandate of restorative engineering. Technology must restore human safety and give time back to the operator. Plant owners should force the deployment of a reversible, low-risk validation test within 48 hours for any new software. Direct investment towards silent, precise operational intelligence, rather than the high-latency transmission of raw data. Look at the executive reporting dashboard for a modern enterprise. You see a picture of perfect control, high yields, seamless logistics, and perfect uptime. But down on the biopharma manufacturing floor at 2 a.m, the reality looks exactly like a frustrated operator slapping a blinking red light just to make it stop. Living biological products like cell cultures and vaccines are highly volatile. A temperature shift of just a few degrees can degrade the product instantly. To manage this, facilities use centralized monitoring systems. Because those central systems process data for the entire warehouse, they are programmed with wide tolerance bands. They intentionally tolerate short temperature excursions and data gaps, so the system doesn't overload with constant alerts. For the frontline handler, those wide tolerance bands mean alarms trigger either too late to matter or so often that they become meaningless background noise. This creates a chain of silent, unrecorded errors. A transport box sits on a loading dock too long. A heavy freezer door is left open for 15 seconds while someone grabs a clipboard. Workers reset the alarms, and the events never make it into the official deviation log. But the biological potency of the product still degrades. These undocumented events quietly drain millions of dollars in scrapped batches and stability disputes directly from the corporate P&L. To see why this happens, look at a single industrial bioreactor and the local sensor tracking its internal pH level. When that sensor detects a subtle drop in pH, the data packet travels across the country to a cloud server. It waits in a massive processing queue before the server finally triggers a delayed return alarm. This dual timeline chart contrasts digital processing speed with biological degradation. While the data slowly navigates the network, the live cell culture's health is already dropping off a cliff. Centralized cloud computing is physically too slow to protect living assets. The mechanical solution is to pull the intelligence out of the cloud and attach it directly to the physical hardware. This is Edge AI. It processes the sensor data locally, bypassing the remote server entirely. Because the compute power is localized, it learns the specific, normal mechanical pattern of the exact compressor it is attached to. If the motor strains or a hinge loosens, the local model recognizes it, triggering an instant alert before the temperature ever fluctuates. When you implement local computation, the environment changes entirely for the people operating the machinery. This bar chart displays network data round-trip times. By moving analytics closer to the biosensors, data latency drops by 40 to 80%. That speed allows operators to catch out-of-spec behaviors immediately. They correct the environment before the product is compromised, eliminating the root cause of pharmaceutical stability disputes. Fewer degraded batches means fewer write-offs. That recovered capital goes directly back onto the corporate balance sheet. We hear constant claims about fully autonomous self-driving bioprocess labs. The actual trajectory of the industry is a hybrid model. It requires human-machine decision-making, supported by highly responsive local sensors. The technology provides clean data without the lag. It cuts through the alarm fatigue and gives the frontline worker the exact information they need, right at the moment they need to make a decision to act.